as we get rolling here, okay, first part here is working on finding missing side lengths, and then leave our answers as radicals. Now, that sheet that I just showed you, I'm going to go ahead and I'm going to re-sketch one of those triangles up here at the top because I want to be able to reference it as we're working on this. If I have a 30, 60, 90 triangle, the general format of that is 1 or maybe 1x, because sometimes the values can change a little. On my 60-degree angle opposite side, it's x times the square root of 3. And then my hypotenuse is always 2, or 2x. Having that general idea is going to help me as I start to do some of these problems. So here's how this works. On number 2, I notice, okay, there's 30, so this is 60. And what I want to do is I'm going to take a second, and I'm going to put these values in along the correct sides. So my side opposite 30 is x, or we'll call it 1x here. My side opposite 60, x square root of 3. And my hypotenuse is 2x. So whichever side they give me, I'm going to do a little algebra to start breaking this down so I can fill the values into the other slots. So this time they gave me the hypotenuse. It's 10, which equals 2x. Well, let's see. If 2x equals 10, what's x equal? 5. So if x equals 5, I just work my way around the triangle sticking in 5s where the x's are at. So my m value is 5 square root of 3. I just plug the 5 in where the x is at. My n value is 1 times 5, or just 5. I'm done. So it's taking the pattern of the special right triangle, given one of the sides, to find my x and then just plugging that in. So there's a little bit of algebra to be going on as we're doing these. But let's take a look at a second one, because again, we want to get used to this, especially since it might have been a little while for some of you. For some of you, may be like seeing it for the first time again. So I look at this next one, I'm like, okay, there's my 30, there's my 60, there's my 90. Let me label my sides again here a little. So 2x is my hypotenuse. This is my x. This is my x times the square root of 3. So I look and I go, oh, they gave me the x equals side this time. Okay. Well, what does that mean? What that means is, for instance, when I'm doing my hypotenuse, I'm just going to multiply this by 2. So in other words, I'm going to have 2 times 8 square root of 3 over 3 to get my hypotenuse side. 2 times 8 is 16 square root of 3 over 3. And the only thing I have to watch for at this point is making sure this part doesn't reduce anymore. I could plug in 16 divided by 3 in my calculator. If I get a decimal, I'm like, oh, well, probably not. Math enter, yeah, it's still getting the same thing. So this is my side A, or my hypotenuse value that I was looking for. Okay, these answers can get kind of big and strange. And then I go for my one side that's left here, and I say, okay, if this is x, I've got 8 times the square root of 3 times the square root of 3 over 3. Holy cow. So I plugged all of this in for x and then just timed it by a square root of 3. Well, 3 times 3 is 9, because again, under the radical, I can multiply those. What's the square root of 9? 3. So this is really 8 times 3, or 24 divided by 3, or 8. That's my B value, or my 60-degree side that I'm working with this. But again, you see, the key is which side do I have, and start figuring out where that x value is so I can start plugging it in. So that's how 1 and 5 and 6 are also going to work. But you're going to be using a 45, 45, 90 triangle instead. But again, you've got the special on your sheet. And if you need a sheet, you've got them up front. So that's part of what we're going to be using the special right triangle sheet for. The other part is on the back of this page. And yes, I know. It says page 1 and it's page 2. These things happen. So I look and I go, okay, find the value for the following trig functions. Identify what quadrant the terminal side's in, what sign it should have, and use special right triangles to find the value. Okay, so let's say we're doing A. Sine of 150. It would be helpful to actually graph the angle. If you still need a protractor, I still have some floating around over there. So I get lined up and I'm like, hey, 150, I can actually see 150 on here. I don't even have to do something fancy. So I get my 150 here. So I'm like, okay, there's 150 degrees. Now what? Well, this again is where your handy dandy help sheet comes in handy, because it tells me every single step to do. Okay, sketch the angle given with your protractor. Okay. Find the reference angle. Remember, the reference angle is how far is it to get back to the x-axis. Okay, so here's my x-axis. To get from 150 to 180, how many more degrees is that? 30. So this is 30. There's my reference angle. There's my 60. I'm always going to get a special right triangle with these. So then again, I use my sides. Again, hence, help sheet. Side opposite 30 is 1. Side opposite 60 is square root of 3. Hypotenuse is 2. So I get all my values. And they'll never change from the one on the help sheet. So sine. What sides do I use for sine? Opposite and hypotenuse. So I'm opposite over hypotenuse. Now the only thing left I have to pay attention to is, what quadrant is it in? Well, I'm like, well, it's in the second quadrant. Second quadrant is where my sine values are positive. So my answer is positive. If this would have been in quadrant 3 or quadrant 4, I'd have still gotten a half, but it would have been negative because of where it lies. So that's one thing we're looking at on these. Okay, that one was pretty straightforward. I am going to throw some twists in here, though. Okay, secant of 225. You're like, ooh, secant. Well, let's deal with the 225 first. Again, when we go to graph, I can start drawing until I get, if I went all the way to here, that's 270. That's too much. Here I'm at 180. How far is it from 180 to 225? 45. So since I'd stopped on the x-axis, I get lined up with the x-axis, find my 45, get that drawn in, and then just like it says on the sheet, find the reference angle, 225 to get back to 180 is 45. Then I read further here. Draw a right triangle back to the x-axis. All right. And then include the lengths of the sides on your special right triangle. We haven't talked about a 45, 45, 90 yet. Their special sides are 1, 1, and the hypotenuse is square root of 2. So 1, 1, square root of 2. So now I'm ready to actually get this figured out. But then I'm like, secant. What's secant the inverse of? Cosine. So secant is 1 over cosine. So I'm like, okay, so if I was doing cosine for this particular one, cosine is adjacent over hypotenuse. So that means secant is the opposite. It's the inverse. Hypotenuse over adjacent. Okay, hypotenuse, bless you, hypotenuse over adjacent. But before you circle, quadrant 1, quadrant 2, quadrant 3, 1, 2, oh, that's the tangent quadrant. This is not a tangent value. Pop the negative on. Lots of detail stuff to pay attention to. Get it drawn, get my sides in, pay attention to what the trig function is, then I got to tell the positive negative part. One more. Because again, I want to make sure we're going okay. Okay, C, let's do 300 here. 300, that's a doozy of an angle. All right. So 300, here we go. 90, 180, 270. 270 to 300, I need 30 more. So line up with that last axis we stopped on. 30 more. Here's my 300. But again, what am I interested in? I'm interested in the reference angle. How far is it to get back to here? 60, because 360 minus 300 gets me this spot right in here. I get my special right triangle drawn. Again, there's my reference. Label my sides. 1, square root of 3, 2. And then I'm ready to figure out what I've got. So cosine, we just got done saying, is adjacent over hypotenuse. So adjacent over hypotenuse. I'm in quadrant 1, 2, 3, 4. Quadrant 4 is cosine. I'm cosine. I'm done. But again, we want exact values on these, and I want to see the triangle, because I know on some of these you could get away with using the calculator and just press a button. It goes, ooh, 0.5, it's 1/2. But I want to see where it's coming from, not just I'm poking on the calculator. So we got 3 of those knocked out. I gave you 3 left to play with. Now we're going to move into the recent stuff, because those 2 had been a little while. So you're like, hey, you got a cheat sheet for this too? I do. It's that little help sheet that you got, the little one. Yours may be pink, it may be blue, depending on when you got it. So this will tell me everything I need to know about graphing. If I have a number in front, that is my A value, that is my amplitude. That determines if my graph gets really wide or really shrinky. For most of you, maybe not all, the chart's been a good thing here. I didn't mess with my degree measures, so my period will be 2 pi. So I just keep the values that are on my little help sheet. And again, there's more of these over by the folders as well. And then my y's, if I ever have an A value, I multiply those by whatever the A value is. Pay attention to what trig function it is. So this time it's cosine. So I'm going to take each of my cosine values and times them by 1/2. And I just work right down my chart. So cosine values times 1/2. And those are the points I'm going to plot. So at 0, I'm at 1/2. At pi over 2, I'm at 0. Pi, I'm at negative 1/2. 0 and 1/2. And again, you only have to graph one cycle. Now, if you wanted to keep going, so it fills the whole thing, that's fine. But as long as you've graphed one cycle, you're okay. So, again, if there's a value in front and amplitude, That's going to determine if my graph's skinny like this one or if it's getting really wide going up and down. But it affects the value part. The next one we do is going to affect the other part. So for number 3, this time we're going to have a period change because I have a b value. So normally my period is 2 pi. But if I have a b value, I divide the period by that value. So that tells me 2 things. First, it tells me that that'll be the last value in my degree measures if I do it right, so it's a nice checkpoint. And there's one other kind of indirect thing it tells me. So my b value I divided. Dividing by 3 is the same as multiplying by 1/3. Here's why that's important. I want to use the times by 1/3 to get my new angle measures. So whenever I get a period change, I get a b value, you're multiplying by the reciprocal of b. So if it's a whole number, it turns into a fraction. If it's a fraction, it becomes a whole number. So what I'm going to do is I'm going to take every one of my angle measures now and multiply them by 1/3. Or in other words, multiply the denominator by 3. So I'd have pi over 2 times 3 is 6. 1 times pi is pi over 3. 3 pi times 1 is 3 pi, but 2 times 3 is 6, and I need to reduce. 3 over 6, 1/2, or pi over 2. And then my last one, 2 pi times 1 is 2 pi over 3. Ooh, there's my 2 pi over 3. So it kind of gives me a checks and balances system to make sure I'm doing this right. No a value this time. So my y value is just taking my sign values and copying them. 0, 1, 0, -1, 0. And going, okay? I'm going to plot these, to which then I run into my next problem. Like, dang, there's a lot of problems with these. Okay, 0, 0, I'm fine. I don't see pi over 6. I don't see pi over 3. Ooh, I see pi over 2. Okay. -1. And I don't see 2 pi over 3. So, Harty, how the heck am I supposed to graph these? Well, you've got some options. If my computer unfreezes, we have some options. For those of you watching video, the uncontrolled power of technology. So, when we're looking at these, there we go. There's a couple of ways I can play this game. One of them is I can look and say, okay, that's like 1/4, that's like 1/6. Well, now let's see, how's this work? Pi over 4 is 1/4, that's like 0.25. 1/6, ooh, 1/6 is less than that. So my pi over 6 is less than 1/4, and I go up to 1. Well, okay, well then where's pi over 3? Well, that's more than pi over 4. 1 divided by 3. But it's less than 1/2. So it's between these two. So pi over 3, get my 0 in there. And then 2 pi over 3, well, I'm not sure on this one either. I see 3 pi over 4. Okay. But this is 2 divided by 3. Ooh, 0.66 is less than 0.75, so it's got to be here somewhere. Back to 0. And I get this little tiny, teensy little cycle right there. And again, I can expand and keep going if I want to, but as long as you've graphed a whole period, that's all you have to do. So again, let the calculator help some if it needs to on figuring out where some of those points that don't match up are going to be. Last one of these, because I want to do one where we combo it. So I'm going to hit the nastiest combo on the sheet, number 6. So I have an a value, And I want to rewrite this one again. We've done these before, but I want to make sure it's been a couple of days. Theta over 4 is like 1/4 theta. My b value is a 1/4. So, let's see here. My period is going to be 2 pi divided by a 1/4. Now, before you punch in your calculator 2 pi divided by 4 and get the wrong answer, reminder, dividing by 1/4 is the same thing as multiplying by 4, or 4 over 1. So 2 pi times 4 means my new period is going to be 8 pi. We're really going to be stretching this guy out. So I'll be starting with 0. I will be ending with 8 pi. I got to figure out what's in the middle. Well, how do you do that? Remember, our period, we're just dividing each angle by 1/4. We're timesing by 4. So I look at my handy-dandy angle measures. 0 times 4 is 0. Pi times 4 is 4 pi divided by 2 is 2 pi. Pi times 4 is 4 pi. 3 times 4 is 12. Divided by 2 is 6, so 6 pi. And 2 pi times 4 is 8 pi. Hot dang, I did it right. So you start to see why I really want to calculate my period in advance to make sure that it's working right. Because if I get to that last number and it wouldn't have been 8 pi, I was like, ooh, something went wrong somewhere. So then my last part is my y value. But I have an amplitude this time. So I'm going to times those each by a half. Sine values each times a half. So 0, a half, 0, negative a half, 0. So I just take them in pieces. And now I'm ready to graph, and I'm happy to say that this time all of my angle measures are actually on the graph. And again, try to remember we're doing curves here. Okay. Not the pointy stuff, but the curves. So again, that's how these are all going to work out. A values, I times the y value. B, I divide my 2 pi by that, and then multiply by the reciprocal to get my angle measures. So you got a few of those to play with. And then our arch nemesis from the last 2 days. Now, here's a couple of things to put some of you at ease, because I think some of you have been panicking a little with these. On the quiz, there will be 3 of these. They will be very straightforward and borderline on simple. They will be much closer to like what you see in numbers 1 and 2 than what you see in like numbers 7 and 8. But I still want to challenge you a little bit. So we're going to do 1, 3, and 7 together. Last thing, now you won't be using your note sheet on the quiz, but I will have all of these written up on the front board. So when you get to this part and you're looking for your change to make, you'll kind of look and go, okay, oh, okay, and kind of go that route. So I'll have them for you. So I look here and I'm like, okay, we always talked about try to turn it into sine or cosine most of the time. So I look for secant. Like, okay, secant. Oh, let's see here. Secant. Secant's 1 over cosine. All right. Sine is sine already, so I'm happy with sine is sine. I'll leave that alone. You're like, but Harty, nothing cancels. That's okay. If I multiply across to make it a single fraction, I take one more peek at my help sheet then, because I'm like, I think I've seen this before, sine over cosine. Sine over cosine. Ooh, sine over cosine is tangent. And I can't get much simpler than that. Like I said, that's more the type you're going to be seeing. I can do some other funky stuff. Like, I can see number 3, and I'm like, okay, tangent squared minus secant squared. Ugh. Tangent squared. Now, can I do... can I do tangent... Can I have tangent squared equals sine squared over cosine squared? I can. So, I'm going to do sine squared over cosine squared, and then secant squared. It doesn't just have to be the Pythagorean identities. We talked before about how even just secant becomes secant squared if I square both sides. So secant squared can be 1 over cosine squared. Now the one thing I'm thankful for here is I have a common denominator already. That's going to make some of this easier. So then I start looking, I'm like, okay, that numerator must be able to change around somehow. So sine squared minus 1. So I start looking at my sheet, and I go, okay, sine squared minus 1. Well, I got 1 minus sine squared, but that's not quite the same thing. Because the 1's positive and the sine's negative, and here it's just the opposite. I can fix that, though. Because remember this from when we were back factoring. If I pull a negative out of there, I can change the signs on both of these. My sign is negative. My 1 is positive. My sign is negative. My 1 is positive. So now I can change this to a negative cosine squared, my numerator. Leave my denominator alone, and you're like, sweet. They're the same. I can cancel them now. That's true. But remember, the negative's still there. But I can get to my answer. Now, like I said, these we're playing with now. I'm going to avoid by any means necessary trying to have anything like this on the quiz, because I want to keep them more simple. But it's still something we need to know because, well, we're going to try some of these out. And then my last one, I'm going to go down to 7. So I look at 7, I'm like, okay, 1 over sine squared. Okay, well, let's leave that alone for a minute. Let's see how this works. Tangent. You're like, tangent. Just a second here. Tangent squared is sine squared over cosine squared. Okay. Sine squared over cosine squared. Ew. I don't like this. It's a fraction over a fraction. But again, let's think about it for a minute. 1 over 1 divided by sine squared over cosine squared. When we divide by fractions, we flip them. So this is cosine squared over sine squared. So I'm like, okay, so this really is just cosine squared, because I multiply across. 1 times cosine squared is cosine squared, and 1 times sine squared is sine squared. So that's kind of slick. And I go, okay, common denominator. Let's get it down to 1 fraction and see if something jumps out at us. I'm like, wait a minute. 1 minus cosine squared. I've seen that. If I haven't lately, I'm going to go back and I'll find it. 1 minus cosine squared. Sine squared. Sine squared divided by sine squared is 1. I'm done. So keep going for sine and cosine, and just keep manipulating using your regular math rules. So like I said, between this review and the actual quiz review that we're going to have tomorrow, where we have the video going and I'm tag teaming and walking around, you've got plenty of time with about 15 minutes today and then probably about another 20 or 25 tomorrow to at least for sure get this knocked out. If you need anything for any of the other parts of the homework, check, let me know. But otherwise, use your time wisely.